To which intervals could we restrict f of x is equal to cosine of x minus pi over 4 so that f of x is invertible? And they show us what cosine of x minus pi over 4, what it looks like, the graph of it. So let's just think about what it means for a function to be invertible. So a function is a mapping from a set of elements that we would call the domain. So my pen is a little off today, so let's see if it works okay. So this right over here is our domain. And this over here is our range. And a function maps from an element in our domain to an element in our range. That's what a function does. Now the inverse of the function maps from that element in the range to the element in the domain. So that over there would be f inverse. So that's the direction of the function. That's the direction of f inverse. Now a function is not invertible. One of the situations in which a function is not invertible, you could have a function where two elements of the domain map to the same element of the range. So both of these elements map to that element of the range. So both of these are the function. But then if this is the case, you're not going to be able to create a function that maps the other way, because if you input this into the inverse function, where do you go? Do you go to that element of the domain, or do you go to that element right over there? And so one way to think about it is you need a one-to-one mapping. For each element of the domain range, there's only one element of the domain that gets you there. Or another way to think about it, you could try to draw a horizontal line on the graph of the function and see if it crosses through the function more than once. And you could see that this is indeed the case for this function right over here. If I did a horizontal line right over here. Now, why is this the issue? Well, this is showing us, actually, let me do a number that's a little bit easier to look at. So let's say I drew the horizontal line right over here. Now, why is this horizontal line an issue? Well, it's showing us that just even what the part of the domain that's being graphed here, that there's several points that map to the same element of the range. They're mapping to 0.5. 0.5. This value right over here, when you input f of that is equal to 0.5, f of this right over here is equal to 0.5. F of this right over here is 0.5. So if you have multiple elements of your domain mapping to the same element of the range, then the function will not be invertible for that domain. So really what we're going to do is we're going to try to restrict the domain so that for that domain, if I were to essentially apply this, what I'd call the horizontal line test, I'd only intersect the function once. So let's look at the graph of the function once. So let's look at these choices. So the first one is an open set from negative 5 pi over 4, negative 5 pi over 4. So that's pi, that's negative pi and another fourth of pi. So that's, I think, starting right over here, going all the way to negative 1/4 pi. So that's this domain right over here. Let me do this in a new color. So that's this. And this does not include the two endpoints. So here I can still apply the horizontal line, and in that domain I could show that there's two members of the domain that are mapping to the same element in the range. And so if I'm trying to construct the inverse of that, what would this element, which is I guess is negative 0.6, what would that f inverse of negative 0.6 be? Would it be this value here, or would it be this value here? So I would rule this one out. So let's see, negative pi to pi. So negative pi to pi, I'll do this in this color right over here. Negative pi to pi. This is so once again, and this is a close, so we're including the two boundaries. We're including negative pi and pi in the domain. But once again, over that interval, I could apply my horizontal line here, and notice, or actually I could even apply the original one that I did in blue, and notice there's multiple elements in the domain that map to, say, 0.5. So what would f inverse of 0.5 be? You can't construct a function where it maps only to one element of the domain. So we could rule this one out right as well. Now, negative 1/2 pi to positive 1/2 pi. So negative 1/2 pi, so that is, so I'm running out of colors. So negative 1/2 pi to positive 1/2 pi. This one is interesting. If I apply horizontal line there. So let's see. But if I apply a horizontal line right over here, I do intersect the function twice. So I have two members of this domain mapping to the same element of the range. So I could rule that one out as well. And I'm left with one last choice. So I'm hoping this one will work out. So 1/2 pi, so then it's an open set. So 1/2 pi right over there to 5 pi over 4. 5 pi over 4. So that's pi and another 1/4. So that's right over there. And let's see. This is, if I were to look at the graph here, it seems like it would pass the horizontal line test. At any point here, I can make a horizontal line over that domain. Actually, let me do it for the whole domain. So you see that for the whole domain. And I'm only intersecting the function once. So for every element of the range that we're mapping to, there's only one element in our domain that is mapping to it. It's passing our horizontal line test. So I would check this one right over there.